Hello everyone, I am Ma Liting. This is my final project proposal for the Computational Astrophysics course. The topic of this project is the tidal disruption of asteroids and comets. So, first of all, I will give an introduction of this project, then I will discuss what I want to do and how to do it. And at the end, I will talk about what result I expect to get. So this is our solar system, and what is related to my project is this planet, the Saturn. It is a massive planet. Its mass is about 95 times the mass of the Earth, and it's well known by its planetary ring. So people ask how the Saturn's ring formed. This is the image of Saturn taken by Hubble Space Telescope, and the composition of the ring is mostly water ice and rock materials. Although there are several different hypotheses about how the ring formed, the answer is still not confirmed yet. One of the well-accepted scenarios says that Saturn's rings probably formed when objects like comets or asteroids pass through the orbit around Saturn. Due to Saturn's strong gravity, they will be destroyed by the tidal force and separated into smaller pieces. And these smaller pieces will gradually spread around Saturn to form its ring. Then let's talk about the tidal force. The tidal force is the gravitational force discrepancy on different parts of the object. So from Newton's law, we can see that the gravitational force F is equal to minus G(m) divided by r squared in the r direction. So here the G is the gravitational constant, and the capital M is the mass of the Saturn. The capital R is the distance from the Saturn's center to the center of the asteroid. And the delta R is the small distance between the location where we are calculated to the center of the asteroid. Because the gravitational force is inversely proportional to r squared, so here we'll get a larger gravitational force, and here we'll get a smaller one. The different value of the gravitational force will stretch the asteroid in this orientation and let it become elongated. Okay, so from Newton's law, we can get the acceleration of the asteroid. And if we rewrite this term with Taylor expansion, we can get this form. And from here, we can see that the first term of this equation is just the central acceleration of the asteroid. And these other higher order terms are the related acceleration from each point to the asteroid center. And what I want to do for this project is to simulate how the tidal force acts on the asteroids or comets. So simply saying, I want to see the effects of these higher order terms in these equations. So next is how to do it. I will perform an n-body simulation to simulate this situation. So first, I assume there is a Saturn without ring. So it's like a naked Saturn. Then I can approximate the Saturn as a point mass. And I will divide the comet or the asteroid into many small elements. So each of them will have different distance to the Saturn. And here is the things that I need to consider and implement it in the simulation. So indeed, I need to consider the gravitational force from Saturn, and the mass of the Saturn is equal to 5.6 times 10 to the 29th power in grams. and I will calculate the gravity comes from each element as well, and I will also include the fraction between each particles. These two parts will prevent the asteroid to be stretched too easily. And finally, here is the result I expect to get. The asteroid will be distorted into different shape like here, and if the tidal force is big enough, it should be disrupted into small particles like this one. So here is the reference, and thanks for your listening.